Hey, what's up? Welcome back. This is day 8 of the advent of code. This one has been the most challenging for me. I've never worked with one of these 7-segment search or the 7-segment displays before, and so I wanted to kind of just go through that. I want to show the solution that I came up with, and then after I did this, I also want to talk a little bit about deliberate practice, because I think when you're watching YouTube videos and when you're learning how to code and when you're trying to just get inspired, it can be really tricky to know how to get better. And so, I wanted to just cover a little bit about deliberate practice, meaning like you go out and you intentionally try to get better. And what brought that to mind was that when I went through and solved this, I didn't want to look at anyone else's solutions. I wanted to like really figure it out for myself. And then after I solved it, I went and I was like, you know what, that was actually like pretty tricky. I've never done this before. Are there better ways to do this? And so I went and looked at some other solutions in Rust and in Elixir, and there are some really cool ways to do this with pattern matching. So what I want to do is kind of take this one a little bit more slowly, show you how I'm thinking about it, and then also talk about how and then try to solve it with Ruby's pattern matching, which is this newer feature in Ruby. But I think it's a really clever way to do it. And so let's jump in and talk about these 7-segment displays. So a 7-segment display is one of these things where kind of you have each of these 7 segments that allows you to make up a number. And so for instance, on the far left here, if we wanted to create the number 0, right, we might, if you kind of like squint your eyes a little bit, you can see a 0 there. And then the next one would be a 1. And so for a 0, everything is filled in except that middle segment, right? And so a 0 in particular has 1, 2, 3, 4, 5, 6 different segments. And so the way that we are going to receive the input for this project or this problem is going to be sort of like letters. So maybe this one is like F, G, A, C, B, D, E, or something like this, right? And so we're gonna have to like decode the incoming letters and figure out like, okay, that's always gonna be B then. Like the middle one will always be B. But the order in which the letters come in is gonna be different every time. All that we're gonna get is the 10 different input values that are sort of randomly ordered, and we have to figure out what the numbers are that represent, or or like the segments that those letters are related to. So we have 0, 1, 2, 2 looks like this. Okay, so here is all of our numbers: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And what I wanted to do is like, let's switch over to a different color here and start talking about this. So there's a couple of unique things that happen as part of this first, or as part 1. Part 1 wants us to just return the number of 1s, 4s, 7s, and 8s. And the reason is that each of these numbers have a unique number of segments. So there's no other number that has only 2 segments. So a 1 has just these 2 segments, and a 7 has 3 segments. No other number has 3 segments. 4 has 4 segments. No other number has 4 segments. And an 8, of course, has all 7 segments. So the first part of the project is to just return the number of 1s, 4s, 7s, and 8s. We're going to add day 8, and we're going to have segment or display or something, .rb, and then we'll have class display, and I guess like day 8 spec.rb, and we're going to require relative day 8 display.rb, and we're going to rspec.describe display. And this is going to say something like it returns the correct number of 1s, 4s, 7s, and 8s. And the input, again, is going to be this like random strings, or like these numbers here. So the input is going to be something like display.parse this thing. And this is so this is kind of like what it's coming in as. So the first part here, you can notice that there is a pipe. There's the pipe operator that separates the sort of encoded side from the answer side. So we have two parts here. We have we have all of the numbers and their representation based on whatever was mixed up. And then on the right side, we have the value that we're supposed to output. And so what this should give us back is a new display. And that display's numbers are going to correlate with this thing. And then like we need to figure out how many of the numbers. So expect display dot simple numbers do equal, and then some number of numbers. So these are all, none of these are 1, 4, 7, or 8 because they're all 5-digit. They're all like made up of 5 different segments. So each of the 5 segment pieces, if we look back here at our numbers, 1, 2, 3, 4, 5. So a 2, 1, 2, 3, 4, 5. 3s, 5s. So a 2, 3, and a 5 are all 5 segment pieces. So none of those answers are going to work for our test. So what we can do instead is we can add in a couple that are like AB, and then EAFB. That should be a 4. And then we want like DAB, that should be a 7. And then ABCDEF. Or let's see, what is the 8 here looks like this. So we're going to add in an 8. And so we'll expect that there is 1, 2, 3, 4, 5 simple numbers. And none of this is going to work yet because we have to go implement parts of the display. Self.parse, this is going to be our input. And we're going to say numbers. I guess like this is, I don't know, how do we want to, I guess like, what is so the patterns, I guess, patterns and then the numbers are input.split on pipe. And then after we split on pipe, we want to map, we want to map those and split again on space. And then we want to map those to integers, to I. And I think that should work fine. We want to return a new display of patterns and numbers. I guess like we want to test out that this parse thing works too. So it parses as expected. And we'll just say display is display.parse. Actually, we'll just do the same exact thing here. And we'll expect that display.patterns oh, actually, we can't map these to numbers. These are not numbers. Oh gosh, they're strings. To equal whatever. We'll just put them. We'll put them in here. So okay, so this is going to look like this. Okay, so like basically all of the different patterns are going to be the pattern portion of this. Next, we need to do the same thing for our numbers. All right, so this should work as expected, and wrong number of arguments. Oh, right, because we didn't actually want to map to I here. Still wrong number of arguments. Got the input. Oh, right, okay, so we need to put an initialize method here. Patterns and numbers. And patterns is patterns and numbers is numbers. And then we'll add some getter methods for those. Okay. And let's see. Wrong number of arguments given 2 expected 1 on day spec. Given 2 expected 1. Oh, this is expect the patterns to be that, and then expect display.numbers to equal this. Okay. All right, now we're crashing and burning because that doesn't have a closing paren. I misspelled numbers somewhere. Okay, so that's passing. Parse works as expected. We expect that simple numbers is going to equal 5. Let's come back over here and we'll say simple numbers is numbers.count, where the length is in like 1 or 2, 3, 4, or 7. Okay, that's passing. And I think this is actually the first part of the test. So focus on the easy digits, consider this large input. How many digits are 1, 4, 7, or 8? And so we go through here and we have to count up which ones are 1, 4, 7, or 8. So we're going to get our puzzle input. This is our puzzle input. It's pretty massive, so we're going to add that here. Input. And okay, so then we want to come back over to our display and add our little file thing at the bottom that says if we're running this same file. Then we want to read all of the lines, and those are going to create different displays. So file.readLines of argv.first.map chomp.map into display.new for the things that we're mapping it into, and we'll have displays and displays.inject. So we want to add up all of the simple numbers. So D, or like A and D, A plus D dot simple numbers. And we want to just print that out. So it puts that. Okay, so day 8, display, and day 8, input. Crashed. Initialize, got the wrong number of arguments. Oh, this should not be new. This is parse. Okay, undefined method plus for, oh gosh, we just want to start at 0. Yeah, okay. All right, 369, was that our answer? Our answer was 369. Okay, so we've got it working for the simple case, but that case didn't really get us very far. So it says, through a little deduction, you should now be able to determine the remaining digits. Consider this first example above. After some careful analysis, the mapping between the signal wires and segments only makes sense in the following configuration. So that's like based on this input, it only makes sense in this configuration where A, B, C are over like in these positions. And then this gives you out the numbers. So like in this case, you take all of these as input, and then you have to figure out where the segments are based on these inputs, because these are like randomly ordered, right? And ultimately you figure out this is the mapping, and you see that in the answer here, anywhere that you see FCABD, FCAD, right? I guess, or yeah, CD Feb or CDFBE. So these are also not ordered the same, but then you end up getting out these values for the numbers. So then like the answer for this value entry is 5353. So this is 5353 based on all the different random inputs. So yeah, so that is kind of like the problem for part 2 is we need to deduce and figure out what the values are. And then what it asks us to do is add all of the output values in this example, and it should spit out some number. So here is our larger example here. It looks like this. And we want to go through, like determine what the actual value is for that segment or that display, and then return that and add them all up. Okay, so this is where it got super tricky in my opinion, because yeah, so going back to the drawing board here. So back on the drawing board, there's a couple different approaches that I took. The first was like, okay, what if I just count up the frequency of like each segment? So here, right, like if we're just talking about this top segment, so we've got 1, 0, right? So that doesn't count. 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 in that top position. So then I like kind of would write like an 8 at the top. And then if we're going to the next section, let's just go on the left. So we have 1, 2, 3, 4, 5, 6. So I put a 6 over here. And then if we're looking at this next segment, 1, 2, 3, 4, 5, 6, 7, 8. So then there's another 8 on that side. Go to the next segment, maybe the middle. So this is our first occurrence. 1, 2, 3, 4, 5, 6, 7. So there's 7 in the middle. And then we go to the left here. 1, 2, 3, 4. So there's 4 over here. And then if we go to the bottom, we have 1, 2, 3, 4, 5, 6, 7. 7 on the bottom. And then ultimately this far right side, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so this is 9. So if the frequency of the segment, or like if the frequency of the letter in the original patterns is 9, then we know that that is for the bottom right-hand side segment. We know if it's 4, it's for the bottom left-hand side segment, right? And then the others, we have 8 and 8, so that we can't really deduce it that way. We have 7 and 7, we can't deduce it that way. But if we have a 6, there's only one 6, and that is for this upper left segment. So we can sort of figure out like upper left, and bottom right based on the frequency in which they appear inside of the original pattern. So that's one approach, is just like looking at the frequencies, right? I'm going to remove all of these. The other way that we can do it is by looking at the intersection of different numbers. Okay, so let me show you what I mean. So if you look at, we know for a fact that we can find 1, we know we can find 4, 7, and 8, right? And so what we can start to do is say like, okay, if I take 1 and I intersect it with 9, or if I take 4 and I intersect it with 9, then I know that I'm going to result with like a length of 2 that are different. So 4 intersect with 9 is going to give me back like 2, right? Or like, not the intersection, but like the set difference between 4 and 9 is going to be 2 segments. And if I look at the set difference between like 4 and 5 or something, that gives us something interesting. And if we look at the set difference between 1 and, 1 and 0, that gives us these 4 segments, 1, 2, 3, 4, right? And so that gives us 4. And I think using pattern matching, we might be able to solve this by looking at the set differences between the numbers that we know for sure. So like ones and 1, 4, 7s, 8s, and 9s. So let's start here, and we're going to try this out. So I've never actually solved it this way. This is how we're going to get into it. Okay. So what I think we want to do is we want to figure out, for each pattern, we want to know whether or not it is a 1. Okay, so we want to go through the patterns and we need to match them. And I guess let's like figure out what the output is again. So yeah, we want to figure out what some mapping where we have like a pattern and that pattern maps to some value. So like, let's see. So the other thing that we can do too is I think we can sort the patterns because each pattern is unique. And that will help us with our or the other thing too, I'm wondering is if we want to make each pattern a set. instead of an array, or instead of just like a string of numbers, if we map it into a set, is that going to give us anything valuable? So Ruby set. Also, Ruby pattern matching is pretty new, and so I was excited to try that out. So yeah, set. We could just convert it to a set. I don't know. Let's just give this a let's give this a whirl. So what I think we want to do is say something like def mappings is something. Okay, so actually, yeah, I guess we got to write a spec for this. So let's see. So mappings returns a mapping of pattern to number. Okay, so in this case, let's actually take this example here and use this as our test. Okay, and then what we want to do is say like display, we expect that display.mappings to equal some dictionary or hash where the keys are like this and the values are like this. So we want to get back basically this. And whether that's a string or a symbol or whatever, I don't, let's make them strings just because. All right, so this is what we expect our mappings to be. Right now we get back nothing. And so we need to have like mapping, and this is going to be something interesting. So the other thing I think might be helpful is to have some methods for each of like 1, 2, well, okay, so let's just do it as variables in line here. So 1 is going to be patterns.find where the length is equal to 2, and then 7 is going to be the same thing but for 3. 4 is going to be the same thing but for 4, and 8 is going to be the same thing but for 7. Okay, and then what we want to do is we want to like go well, okay, we need a couple of things. We need the length of, actually, yeah, okay. So like the way that the pattern matching works in Ruby is you say case, and then you have some input thing, and then you say in, and then you have your matcher, and you can have else, and you can have end. So in this case, what I think we want to do is start with length. So so pattern.each do p, or pattern, whatever, patterns.each do pattern. Okay. And if the pattern.length is our first attribute, then if it's 2, then we want to return then we return the value 1. If it's 3, then we return the value 7. If it's 4, we return the value 4. If it's 8, we return the value 8. Okay, and then I don't think we need this anymore. And I don't know how we're going to collect it up into an actual thing. But the other thing that we need now is to know, like, after we do the intersection of 2 patterns, what does that actually look like? So, okay, so we do want these ones. We do want 1, 1, 4, 7, 8, because these tell us something valuable. So for each pattern, if the pattern, let's see. So if the pattern intersection with 1, what does that give us? The other thing is that, like, yeah, okay. So we need to figure out 2. In something gives us 2. In something gives us 3. So what I'm thinking here is that, let's say we have something like A is the set, or like, yeah, set, or I guess we have to say require, well, set.new. Oh, wow, okay, before you had to like require set, now it's like just included there. Okay, so A is set.new of like 1, 2, 3, right? And then B is set.new of 2, 3, 4. And let's say like A intersect B, what does that give us back? It gives us 2 and 3. So what about minus? Okay, that gives us 1, which is the leftover thing. And then if we do like dot length, A dot intersection B, is it the same? Yeah, okay. So, all right, so to get 0, we want the length, the pattern length should be what? How many segments are in a 0? And that's a 6. And then I guess the other part of this is, yeah, intersection. So let's map all of the patterns when they come in. Let's make them sets of the characters. So we're going to map the pattern into set.new of pattern.chars. And that way our patterns are all sets. Is that what we want? I think so. And S is set.new of 1, 2, 3, s.length. Okay, yeah, that gives us what we expect. Okay, so then if we have all these sets, what I'm wondering is if we can do something like one diff or something, and say like pattern minus 1, and this will give us like a length. And then we can pass this as the second pattern match thing. So 1 diff here. And then all of these need to have a second argument now. And then also like, I guess 4 diff and pattern minus 4 dot length. 4 diff. Okay, so then, so a 2, the length of a 2 is 5. The length of a 3 is 5. The length of a 5 is 1, 2, 3, 4, 5. 5. A 6 is 6. And a 9 is 6. Right? 6 patterns. Okay, and or like 6 length. Okay, so for an 8, we don't care about those. For a 3, okay, so the difference between a 3 and a 1 should be 1, 2, 3. So we should get back 3 here, I think. The difference between a 6, I don't know. I don't know. 4 doesn't matter. We don't need, okay, yeah, 5, or for a 3. Wait, we already did 3. What were we doing down here? This is, okay. So 3, I think. I don't know. I don't know what I'm doing. Let's just see. Let's just see what this does. So patterns dot each do pattern. So I guess we're just going to run it and see what happens. Okay. No matching pattern error. Interesting. No matching pattern error. That's cool. I guess that's okay. So like, yeah. All right. So what do we want to do here? I guess 1 diff and 4 diff. Does that give us enough? So if we're trying to figure out 0, the difference between 0 and 1 is going to be 1, 2, 3, 4. So that should be a 4. And we should get back 0. Let's actually just try this. Yeah, let's add a bybug. Also, I think this only works with Ruby 2.7 and above because pattern matching is pretty new. All right. So the pattern is the set A, C, E, D, F, G. Okay. And then 1 is the set of A, B. So the difference between this thing that we got in, which is 1, 2, 3, 4, 5, 6, 7. So the first set here is an 8. The value is an 8. And the difference between 8 and 1 is 5. And I think that's fine, but we don't actually care about that. 4 diff is 3, because if you have a 4, The only ones that are missing is the top, the bottom left, and the bottom. So that's right. And then if we did this thing, exception, what do we get? No matching, 753. Okay, so then I think to get that first one working, yes, so this should be 7 and then nothing, nothing. All right, let's try this again. Okay, we did get an 8 back. So then mapping has that pattern as the set, and then the value is 8. So that worked as expected. So then one diff for, or I guess what is our pattern this time? So the pattern this time is 5 different letters, and the one diff is 4, and the 4 diff is 2. So, and the length of the pattern is 5. So we've got like 5, 4, 2 is what we're matching on right here. And I don't actually know what this letter is. C, D, F, B, E. C, D, F, B, E. So yeah, I don't know if this is gonna work. It's definitely not a 2, but whatever. And then if we get, let's see, pattern again, another 5. So that's gonna give us another 2 mapping. Yeah, so we're incorrectly marking these as 2s because we don't actually know more about the difference there. So the pattern here is again 5. Pattern is 3. So this one we should get back a 7. And we did. Okay, cool. The pattern here is 6. So this could be a 0, a 6, or a 9. The diff, one diff is 4. So it should be a 0. This should be a 0. So we should get, the length should be 6 and the one diff should be 0. So I think we should actually get a 0 here. And we do. Nice. Okay. So I think we've got 0 figured out. Let's just keep track here also. So we have 1 figured out, 4 figured out, 0 figured out, and we'll kind of like keep working our way through this. So the pattern this time is 6 again. The one diff this time is 5, which I think might be a 9, right? The difference between 1 and 9 is going to be 1, 2, 3, 4. Ooh, no, it's 4. Okay, so the difference between 1 and 6 here is 1, 2, 3, 4, 5. Okay, so the one diff should be 5. And the length, so pattern.length is a 6. So we should have like 6, 5, and then nothing for a 6. Okay, so then let's go back over to the number 6, 6, 5. That should give us our answer, I think. Okay, and then thinking about this again, that one is fine. The 2, so if we're looking at a 2, the diff between a 1 and a 2 is going to be 1, 2, 3, 4. Okay, so that should be a 4. And then the diff between a 4 and a 2 is going to be 1, 2, 3. Okay, and then for a 3, the diff between a 1 and a 3 is 3, and the diff between a 4 and a 3 is 2. 2. The diff between a 4 and a 4 is nothing. 5. Okay, that has 6 segments, and the diff between a 5 and a 4 is 2. And the diff between a 5 and a 1 is 1, 2, 3, 4. Okay, so at the end of the day, too, we want to make sure that none of these are duplicates. And some of them are probably like unnecessary, like we have more than we actually need. But yeah, so the length of a 9 is a 6, and then the diff between a 9 and a 1 is 1, 2, 3, 4. And the diff between a 9 and a 4 is 1, 2. All All right, so let's see if this works as expected. All right. Oh, okay, so exception. No matching pattern 542. 542. So 5-4. We have 532, but no 542. Okay, so these are the only two that could be 5 something, right? Those are the only two that have a 5 segment thing. Or does a 5 also? Hold on a second. So 1, 2, 3, 4, 5. Oh yeah, 5. This should be a 542. All right, let's try this again. Okay. Hey, we got super close here. So I think we might actually be cooking with gas here. So let's return mapping and see what we get. So let's see. So if we return mapping down here, the other thing is that like they're not in a set, but we can do something like set.new of this thing .chars. Ooh, there was just one different. What is this? CEBF. Oh, wait, what? We thought it was a 0, but it was actually a 9. Okay. So close. So close. So we thought it was a 0, but it was actually a 9. So 6, 4. All right, so what is the difference between 4 and 0? 4 and 0. So 4 is 1, 2, 3. So that should be a 3. All right, let's run this again. Hey, we've got it passing. All right, so this is super cool. All right, so this pattern matching thing. Okay, so we didn't talk about a couple things. One is like, what is the deal with an underscore? So the underscore says ignore that part. So here what we're doing is we're creating a pattern. So our pattern is like, what is the length of the incoming segment? What is the difference between our set segment and whatever the pattern is that we're considering? Our 1. What is the difference between our 1 and the pattern we're considering? What is the difference between a 4 and the pattern we're considering? And then by doing pattern matching based on those different lengths, we're able to uniquely identify all of these. There was another solution that I saw that was pretty neat. They mapped each of the letters to a certain value and then multiplied or something, and like the multiplied the like product of all of the different possible segments gave you some pattern, and then you can use that to derive the other numbers, whatever. Okay, so this is all right, so we've got our mappings. Let's just say that's like looking good, and that was super fun. So I've never used pattern matching before in Ruby, and this is I don't know, it seems cool. And like very rusty or elixiry. Pattern matching is much more common in functional programming. Okay, so the idea is that now we have to take each of these mappings and we have to convert our like output number thing into some actual number thing. So I think we also want these to be mapped into set.new of like the characters for the numbers. Just simplify this a little bit with the numbered whatever. Okay, so we've got our numbers. Now we want like our output number. And the way this works is we're going to go over, we're going to iterate over all of the numbers. And that's going to give us result is this thing, result dot join, I guess. Like we want to create a string value based on these mappings. So mappings at n, I don't know if that's going to work. If the order of the set or something is different. Let's see. So mapping at n dot 2s dot, yeah. So we want to map the numbers to their number value, and then we want to join them. I don't know, maybe this will work just like this. Dot 2i? I don't know. So let's see. Okay, so given this same thing, we should expect that display.output number to equal, I think it's like 5353. Let's see if that's what we get. Mappings. Also, we don't want to call mappings every single time, so we're gonna let's cache this. So let's call this @mapping and @mapping, and we will. So if we'll just return @mapping if @mapping, and run this again. Okay, so that gives us the right answer. So now what we want to do is we want to iterate over all of those and figure out what those numbers are supposed to be and then add them up. So based on, let's just run it based on our input. So instead of simple numbers, we want to do output number and just see what we get here. Crashed. Uninitialized constant display set. So I thought require set. I'm pretty sure, I don't know why it's available in Pry, but it's not available elsewhere. All right, so what is this? All right, this is our number, 1,031,553. So we are correctly solving part 2. We sort of breezed through that a bit, sort of parts of the solution, but I also wanted to just show you what my original solution was, just so that I can show you how I'm doing these a little bit differently, or how I learned this new way and did it a little differently. So the first time I solved this segment thing, I did create a mapping, but the mapping was okay, I'm going to call each of these methods 0 through 9, and each method I'm going to try to figure out is this a 0 or not? So I had a method called 4 and a method called 3 and a method called 2 and et cetera, et cetera. But each method I was also trying to figure out does it include the bottom left or the top right or the other side? And so I kind of worked my way through a bunch of different possibilities, and the outcome was this massive solution, 156 lines, which I'm not super proud of. This one is 67 lines, is pretty. If you can figure out this mapping situation, it's a much easier to read and follow. So much more excited about this pattern matching thing. Also, pattern matching in Ruby is cool. So we learned about sets today. We learned about pattern matching and set intersection and set difference and whatever. So this was a fun and challenging exercise. So hopefully you enjoyed that. And if so, would appreciate a like. And otherwise, we'll see you in the next one. Cheers.